Hello everybody, in this video I will show you how to define an ideal model for a PMOS transistor in enhancement mode. So first of all we go to the library and we select our component PMOS, we place it on the circuit and then we do Control, right click and we change this name, the name of the instance. I've already done this, so I delete this one. My transistor is here, the name is PMOS_E. And so I define this directive dot, I say like this, directive, and then I copy here this text dot model PMOS_E, the name of this instance, PMOS, the family name, and then the parameter. The parameter, the result current will be negative. The conductance parameter is the double of my conductance parameter. See the first comment for more explication. And then lambda equals 0 means that the model is ideal, so that the drain current does not depend on the voltage between drain and source. So I build up my circuit, I bias with the negative current, negative voltage, the gate source difference, and the same between drain and source, negative. So first of all, I run this operating point. Sorry. So first of all, I will comment this, and so I delete this one. And now I run my operating point simulation. Operating point, okay. So I have my DC values for the circuit, and if I have done correctly my mesh and my equation, I will have a current between flowing from the source to the drain of the transistor of 4 milliampere. Now I do another simulation with two sources. So I uncomment this. And my simulation now is I vary the gate source, the gate source voltage between -3 and -4.5, and the drain source voltage, the V1, between 0 and -10. So, okay, I run the simulation, and now I measure my drain current, which is negative, in the sense that it's flowing from the source to the drain. So I have negative voltages here and negative value of the current because it's flowing in this direction. Thank you for watching. I hope this could help.